Well, good afternoon, everybody. I'm Dan Hewitt, and welcome to NASA's Johnson Space Center. Two astronauts are getting ready to take the first spacewalk of 2016 just 3 days from now, so we're here to hear a little bit more about that and what's ahead for the crew of Expedition 46. Joining me today is Kenny Todd, the International Space Station Operations Integration Manager, Royce Renfrew, who's going to be the Flight Director for EVA number 35 coming up on Friday. And then also on our panel is the lead spacewalk officer, Paul Dumm, who's going to be walking through all the specifics of this EVA coming up this week. So with that, I will pass it on over to Kenny to kick it off.
Oh, thanks very much, Dan. And first of all, Happy New Year to everyone. It's great to see everybody again as we turn the corner, another year of ISS operations. At this point, we're about at the midpoint of increment 46. Scott Kelly, Mikhail Kornienko, they're slowly rounding up their 12-month stay on orbit. They'll be coming home here in early March, along with Sergei Volkov, and so we'll be doing a lot of good human research type of data collection over the next couple of months here as Scott and Mikhail are finishing up the increment. Tim Kopra, Tim Peake, and Yuri Malenchenko are finishing up their first month on orbit. Things are going very well. They've adapted very well, and as you'll see earlier, have done already quite a bit of work over the last month. We just completed a very busy December. We saw quite a bit of vehicle traffic to the station. We did a crew exchange. We brought home Kjell Lindgren, Kimia Yui, and Oleg Kononenko. Everything went very well there, and as I said earlier, we got Tim, and Yuri on orbit and nicely adapted. So, also in December, we saw a return to flight for the orbital Cygnus module. It turned out to be our first berthing to the Node 1 Nadir port, and that all went extremely well. And we're still processing that Cygnus module today. Talk a little bit about when we're going to release that module here shortly. But we also saw towards the end of December the arrival of 62 Progress, which in some ways represented a return to flight type of opportunity for our Russian colleagues. It was the first time since they had their issue with their Progress back in April that they launched this combination of the launcher with this Progress. And so anyway, everything went very well for that as well, and we're glad to have 62P Progress on board. In addition to all that vehicle traffic, we threw in a bonus spacewalk around the Christmas time frame. We had a translation cart that was out on the truss that we tried to move it to support some payload activities, and we found ourselves with that cart stuck in between work sites. Having that cart and not at a work site was going to be problematic for docking the 62P Progress vehicle, and therefore we made the decision to execute a spacewalk. We did it with about 4 days of notice, and from the time we saw the problem till the time we went out the hatch. So that was pretty remarkable in and of itself. But the crew and the entire engineering and ops team did a great job at putting that plan together and execute it. So in the midst of all that, we've been continuing to do the science, a lot of human research in this time frame, especially with the new crew coming on board. Have a lot of requirements just after arrival to get a lot of data, human type of data. So everything going very well on orbit at this point. As we turn the corner, looking into the new year, we're really focusing on the SpaceX return to flight mission. At this point, our SpaceX colleagues did in September or December launch a vehicle on their new launcher, and had very good results. They had a post-flight review last week, and all indications are that the data was very, very positive coming out of that launch in December. We're continuing to work with them to finalize the plans for the launch of the Dragon to the station. We'll probably be hammering that out over the next week or two here and try to get that on the plan. So I know they've got a couple of more launches that they're supporting, and we'll be watching those and working with them to get our station plan sorted out as well. In parallel with that, as I said earlier, we have the orbital Cygnus module that's currently sitting on the Node 1 nadir port, and we're finalizing our plan for when we're going to release that module. Originally, we were going to do that here at the end of January, but we're looking at our options for hanging on to it a little bit longer, just to give ourselves an opportunity to keep station clean, get as much trash off as we can when that module departs. And so we'll be working through that over the next few days here. And it's because of some of this vehicle traffic that brings us here today. We as most of you know, back in the November timeframe, Friday the 13th to be exact, we lost the channels to one of our power channels on board the station, and that is something that we could live with. We chose at the time to say we would could live with it for some period of time while we watch the vehicle traffic. Since that time frame, as things have started to settle out, we've asked the team to try to protect, maybe in January, an opportunity to do an EVA, and the team's done a real nice job at pulling that plan together. So we're here today to talk about this EVA to go repair this power channel. As most of you know, we have 8 power channels. We're down 1. It's from a station perspective, we could live in this state for quite a while, but the reality is that if we were to have an additional failure in another channel, we'd probably find ourselves a little more strapped, and given the hole that's opened up here in January and the readiness of the team to go execute the EVA, we think it's probably about time to go get this work behind us. So anyway, the failure that we've seen in this power channel is very similar to one we saw back in the 2014 timeframe, October. We had an electronics box failed called a sequential shunt unit, and when you look at the signatures that we saw back then to what we saw with this particular power channel, which we call power channel 1B, they very similar, and based on what we know about the failure of the other box, there's little doubt in our mind that the cause of the problem is indeed the sequential shunt unit. So the EVA is really going to be focused on going out and replacing that box. We have a spare on board. We did a checkout of that spare back in December, and it checked out very good, no issues going forward with the spare. This particular box helps us to control the voltage that gets sent downstream to our different payloads and systems hardware. When you think about these solar arrays, they generate an awful lot of current coming down the solar array towards the electronics, and we really need something in the path there to help regulate the voltage and the current that we send downstream. And this particular box, when it's not working or not working properly, then we run the risk of potentially damaging some of the downstream units. So that's why we elected to keep the channel isolated, not have it in the mix. And once we get this sequential shunt unit replaced, we should be able to reintegrate the channel and get back up and running again on all 8 channels. So anyway, when we go out, the EVA itself to replace this SSU isn't going to take the full 6 or 6.5 hours. Royce and the team have come up with a set of other tasks that are good work that we can go buy down. Some additional tasks that we've had on our plate for quite a while, specifically to support some of our commercial crew vehicles in the next year or two, and as well as some other systems maintenance. We tend to carry a log of things that when we can get to them, that we like to go out and try to get that work behind us. So these guys have done a nice job at filling in around the replacement of what we call the SSU, the sequential shunt unit, and make it a nice full EVA. So anyway, we conducted the mission management team review yesterday with the entire partnership. A little bit of open work left, but nothing that is significant, and crew seems well rested and ready to go do the EVA and understands the task that Royce and the team have laid out. And so We polled the entire partnership yesterday. Everybody was go. And at this point, we'll go close out that open work and try to get this EVA done and behind us. So with that, I'll turn it over to Royce and let him talk to you a little bit about the specifics of what we're going to do.
Okay, good afternoon. I think I'll start just talking a little bit about the personnel that are involved in doing all this. Kenny mentioned that we did an EVA back in 2014 to replace a similar unit, the 3A sequential shunt unit, or SSU. That EVA was actually performed by Reed Wiseman and Barry Wilmore. It was actually EVA 28 in 2014. So we're going to have Reed Wiseman on console with us when we're doing this activity. The person that you'll hear speaking to the crew most often during the EVA, called the ground IV person, will be Reed. He brings obviously the history that he has in doing a very similar task on that other EVA. Scott Kelly, the commander, will be the suit IV. Scott's job in this EVA is going to be to get the crew in and out of their suits. There's a very detailed process for being able to get a crew member ready to go do a spacewalk. It involves getting them all suited up, make sure all their tools are configured correctly, changing out Medox canisters, and just doing a great deal of work in the airlock to get both crew members ready to go. If you saw the EVA that Kenny mentioned earlier that we did in December, that was the job that Tim Peake did for that EVA, was the suit IV task. So Scott will be doing the suit IV for us, and then for the EVA itself, Tim Copra will be what's called EV1. He'll be the crew member that's wearing the red stripes on his suit. And Tim Peake will be EV2, who has the white stripes, and this will be Mr. Peake's first EVA, Mr. Copra's third EVA when we come out the hatch. Kenny talked a little bit about the SSU itself. If you could throw the graphic up that shows the space station. So the little circle in the center of the station is where the airlock is. That's where the crew's going to come out. And then they're going to translate all the way down the truss, all the way to the end of the very starboard end of the truss, which is where the sequential shunt unit itself is located. The ISS is powered by solar arrays, solar energy only. And there you can see the 8 pairs of solar arrays that we have for powering all the ISS loads. The SSU that we're after is on the 1 Bravo channel. The channels are labeled 1 Alpha, 1 Bravo, all the way through 4 Bravo, so there are 8 channels. We can operate the station, as Kenny said, on 7 channels. It's very much like your power company that provides energy to turn on these very bright lights that I'm looking into here, for example. They might have multiple power generation facilities, windmill or wind turbines or hydroelectric plants or whatever, and if one of those plants needs to be shut down, that doesn't turn off this light. Same config that we have for the ISS. We have 8 power channels. We can support all the loads that we need to with only 7, but it would be much better if we could get back to our nominal config of 8. That's the primary objective of this EVA, is to go out and swap out that SSU. The SSU failure prevents us from using the 1B channel. Then, as Kenny said, we have a couple of other activities that we will do during the EVA to round it out, and I'm looking forward to go do this on Friday. With that, I think I'm going to turn it over here to Paul Dumm, who is my lead EVA officer, and he's going to tell you a little bit more of the details about the activities that we'll be doing.
All right, well, before I jump into the details of the activities, I'd like to mention that Tim and Tim have gotten to practice most of these tasks in the NBL, the Neutral Buoyancy Laboratory, before they launched, and they've also been studying products and procedures we've uplinked since they've been on orbit to get ready. We have a brief video clip of Tim Peake practicing using a virtual reality trainer to practice some contingency response during the EVA. Now, as has been mentioned, one of the key challenges of replacing the SSU is that it has to happen at night because we need to protect the crew from the power that would come from the array. And so this time pressure means it's critical that the crew is ready to step into contingency procedures quickly if necessary. So the crew has studied hard and they are ready to go.
I'd now like to go to a video animation of the EVA, which shows some details of how this EVA will be conducted. So we're starting by zooming in on the airlock. This is where EV1 and EV2 will egress to begin the EVA. EV1 will egress first. He'll be the one wearing the red stripes. And he'll bring some tools and equipment for the SSU R&R with him. He'll be followed by EV2, Tim Peake, in the white stripes. Tim Peake will be carrying the spare SSU out to the work site. Before the crew leave the vicinity of the airlock, they'll take a few moments to attempt stow some other tools and equipment for subsequent EVA tasks on the outside of the airlock where they're easily accessible. Once that's complete, EV1 will translate to the starboard CETA cart, where he will retrieve a foot restraint, which he'll use for worksite stabilization at the SSU. Once he has retrieved the foot restraint, he will connect the safety tether anchors for both crew members to handrails on the end of the S1 truss segment. Connecting the safety tether's anchors out here will enable them to reach all the way to the SSU worksite, which is on the far end of the truss. EV1 will then translate to the SSU worksite, where he will install and set up the foot restraint, positioning it to give him good access to the SSU itself. Once that's complete, he'll stow the tools and equipment he brought with him where they're easily accessible. Meanwhile, EV2 will also translate to the SSU worksite. And when he arrives, he will work to stow the spare SSU where it's within easy reach for the R&R. He'll then position himself where he can get good visuals on the SSU worksite and easily access the tools and equipment that have been brought out. EV1 will ingress the foot restraint and verify that he's in a good position for the SSU R&R. Crew will wait for the beginning of night, and when that occurs, they'll begin the SSU R&R. EV1 will remove the failed SSU and present it to EV2 for inspection, then stow it on his BRT so it's out of the way as the crew retrieves the spare SSU from the bag. EV1 will then install the spare SSU and bolt it down to the space station. Once that's complete, the crew will work together to put the failed SSU back in the bag that the spare SSU originally came out in, which EV2 will carry back to the airlock. EV1 will work to clean up the work site, and then will follow EV2 back to the airlock, dropping off the foot restraint on his way. EV2 will place the failed SSU back inside the airlock and be joined by EV1. EV1 will trade out some equipment, and then begin his translation to the NPV work site for the next task. On the way to this work site, EV1 will stop and drop a cable on the port side of Z1. It'll be waiting here for EV2 to connect later in the EVA. Then EV1 will continue to the NPV. This is a non-propulsive vent work site where he'll be installing this non-propulsive vent. In order to install the NPV, he will first remove a cover plate that was installed on the same location where the NPV goes, and then place the NPV on the end of Node 3. Here we have some NBL video of the crew practicing this task. You can see that the clearance between Node 3 and PMM is very tight, making this a challenging work site for the EV crew. Once installation of the NPV is complete, EV1 will translate to the aft side of the vehicle, and specifically to the aft side of PMA3. Here, he will release a PMA3 launch restraint bracket. This will free some cables, which will be disconnected on a subsequent EVA, allowing the PMA3 to be relocated to an alternate location on space station. Once this is complete, EV1 will translate back to the airlock, where he will drop off the tools and equipment he used for the NPV, and pick up an empty bag, which he will use for the retrieval of the CP9 luminaire. So that's camera port 9. The light has some burned out light bulbs. So he'll translate out to this work site, retrieve the luminaire, which you can see here in white, and he'll place that luminaire in the bag he brought out with him. Once he has retrieved the luminaire, he'll do a few cleanup tasks at the work site and then translate back to the airlock. Meanwhile, EV2 will have retrieved the IDA cable bag. So this bag contains a cable which will be used to provide power and data to the IDA, an international docking adapter. EV2 will translate to the nadir side of the lab, temp stow the cable bag, and begin routing the cable. First, he'll route a leg of it aft to node 1 and connect on the nadir side of node 1. He'll then retrieve the EPIC MDM leg of this cable and route it zenith on the lab, and then port across the vehicle. As you can see from this flyby, one of the key challenges EV2 Tim Peake will face during this portion of the EVA will be the tightness of the translation path and the number of other cables that present snag hazards for him as he goes. Once he has completed routing the cable to the port side of Z1, he will connect it to the EPIC MDM cable, which EV1 left for him earlier on the EVA. He will also make 2 connections of the EPIC MDM cable to pigtails that were left out on another cable called the MLM Ethernet cable on a previous EVA. Once this is complete, he will return to the IDA cable bag and retrieve the third and final leg of the IDA cable, which he'll route forward along the lab, and then zenith and forward on node 2, leaving it for eventual connection to the international docking adapter. Once this is complete, he will clean up his worksite and return to the airlock, and that will conclude the EVA. All right, well now I have a couple items I brought with me related to the SSU R&R that I'd like to show you. The first is this bolt, which is called an Acme bolt. It's the type of bolt that holds the SSU into the space station. This is the stanchion, which has the threads which the bolt attaches to. So if everything goes smoothly, it's as simple as turning a bolt to install the SSU. However, we've had some difficulties on previous SSU installation and other boxes that use this type of bolt. So we've had the crew make up a number of contingency tools which they could use if they encounter difficulty. One of them I'd like to show you is called, for obvious reasons, the toothbrush tool. So if there were difficulties, if there was debris, for example, in the threads of where the SSU installs, the crew could use this tool to clean and lubricate those threads, and that hopefully would make it easier for them to install the spare SSU. Now, before I turn it back over to Dan, I'd like to recognize a couple team members who've made this EVA possible. On the EVA execution team, we have Devin Bolch, Brian Alpert, James Galstad, and Sarah Corona. And on our EVA increment team who've helped prepare the suits and tools, we've got Jackie Kagi, Sandy Moore, and Costa Mavridis. With that, I'll turn it back over to you, Dan.
All right, thanks, Paul, and thanks, Kenny and Royce. Right now, we will open it up for questions. Just a reminder, if you're on the phone bridge at this point, you need to press *1 if you have a question to get into our queue. We're going to start here in the room and then go to the phones. I'm going to start left from right like I always do. We'll go with you, Mark.
Hey, thank you, Mark Carreau for Aviation Week. As best you know, and I realize you addressed some of this in the opening remarks, but when are you anticipating the IDA-2 arrival, and even roughly when do you think you can relocate PMA-3 if you're successful with this spacewalk?
As far as when we're going to try to fly the IDA, I think over the next week or so. I mean, our focus right now is really trying to get SpaceX 8, which doesn't have the IDA. It'll be the follow-on flight, which we refer to as SpaceX 9. Clearly, the flight program that we have today is out of date, and we're in the throes of trying to work with our SpaceX colleagues. They have other launches they need to support. We're also interested in those guys being able to get the data they need. We don't want to pressure them into trying to get to launch for the Dragon. So, in terms of when the IDA might fly, I guess I'll beg off on that question. Let us finish some of that coordination with those guys, and we'll get that out to you here in short order.
It's a 2016 activity.
Absolutely. Yes. And again, I think from a program perspective, seeing these guys fly in December and having the good success in their post-flight review last week, again, all very encouraging. And again, they've got a couple more flights they want to try to fly here in relatively short order. and we're in those discussions with them right now, trying to lay out the plan for the rest of the year. So absolutely IDA 2 we're looking at this year. We're starting to put our EVA plans in place to target when we think it might be there. As far as PMA 3, we can try to do that at any point here during the year. I mean, that's a matter of just doing the EVA planning to move PMA 3. If I had to throw a spitball at a schedule right now, I would say out in the fall sometime. We might take a look at trying to do it, but to be honest with you, Mark, that would just be a guess at this point. So it won't be any time in the spring and early summer for sure.
Okay. Bill?
Bill Harvey, CBS for Royce. What is the sparing situation on SSU since this is the second one that's failed? Is there anything generic, or are they totally independent failures, do you think? And then when do you hope to be able to get a spare up? And I've got a follow-up.
So the 3A SSU that we did in EVA 28, we brought that one to the ground, which was good, so we could get it back and do a post-mortem on it. That particular SSU actually failed twice on us. The first time it failed, we managed to recover it. Failed originally in 2012, and we recovered it, and then it failed again in 2014. We did the R&R on it. Based on the post-mortem that we did on the 3A SSU once we got it on the ground, we don't think that there's any systemic issue with the SSUs on the vehicle. I don't know the answer as to whether or not we're going to be able to get 1B back on the ground. I'm sure the program is interested in seeing if we can find some space on a Dragon vehicle to bring this other one back to the ground. The SSU that we're going to install is the only remaining SSU that we have on the vehicle. I believe that's a true statement. There are no other SSU spares on the vehicle. I believe there's one on the ground, if I remember those conversations correctly. So we'll be looking at manifest and to get that one up to ISS here eventually.
And the second question is, it's the dumb reporter's question, but you do this in Eclipse, obviously, but what's the actual danger, since you guys build everything to such tolerances anyway? I mean, is it arcing? What would happen?
So it's a solar, right? So it works off of electricity, or it generates electricity out of sunlight. When it's not in sunlight, it's not generating any electricity. So what you're interested in there, and particularly for removing the failed SSU, is because we don't know what actually caused it to fail. It could have a short inside it. So what we don't want to do is be removing that with a potential short that could cause arcing and sparking as it comes off. So we do it during the night pass. That way we're absolutely guaranteed that there's no power flowing through there because there's no sun to generate any electricity.
Robert?
Robert Perlman with Collect Space. Sort of building off that question, night passes 45 minutes. What's the nominal amount of time that you project will need for that install? And if you were to run long because of a problem and we're approaching daylight, what's the contingency for when you have to call it off and then resume work?
So I'll answer the first question about the night pass, and I'll let my EVA officer talk about some of our crib sheet stuff. So the night passes that we're targeting here in January are 31 minutes long. It's all based on solar beta. Solar beta for an SSU R&R, it needs to be somewhere between negative and positive 10. We get to negative 8.5 on January the 15th. So that's our beginning of our maximum length of our night passes, and it's 31 minutes long. The objective of this EVA is to do the SSUs. Kenny mentioned that we had some other stuff we would do, but in reality, if we don't get the SSU done during the first Eclipse pass, we'll fall back to the second Eclipse pass or potentially to the third Eclipse pass to get it done, and the rest of that stuff will just fall off the timeline. And I'll let Paul talk about some of the crib sheet items that we have planned.
Yeah. So you were asking how long it would take. If everything goes completely smoothly, probably on the order of 15 minutes. So we do have a little bit of margin. Now, when we did this a little over a year ago, we used almost all the margin we have. You asked about contingencies and what we were looking at. You know, there's this fairly simple for the bolt to thread in and out, but what we found that sometimes we get debris in there, sometimes we've had other challenges. So one of the first things we'd have the crew do is kind of slow down, stop using a power tool and start using a ratchet wrench so that they can kind of get a better feel for whether or not this bolt is binding, try and finesse it out. If that doesn't work, we have some other tools out with us, larger wrenches, those sorts of things, which will enable us to put more force on here. So that would be our fallback plan. And additionally, as I mentioned, we've had the crew build up a number of contingency tools, of which the toothbrush tool is one. So if when they got the failed SSU off, they noticed that there was debris damage, or we just thought that they had so much trouble doing it that there was likely to be debris in this threading, we could use those contingency tools to clean this stanchion out and give us a better chance of success installing the spare SSU.
If they were to, if you were to run into a situation where you got the new one installed but it wasn't bolted down and you were approaching daylight, can you leave it safely sitting there and wait for the next pass, or do they have to?
So we have a zone, a portion of the bolt turns where we can safely leave it, and we can basically throw a tether on it just so we know it's secure. And there's one portion where we don't want it almost connected, just because that puts our electrical pins close but not quite touching, increases our risk of that arcing and sparking. So we've talked to the crew. They know not to have it almost in, to have it only beyond a certain point. We also know that we can, if necessary, leave no SSU installed from one eclipse to another, and that's another contingency we've looked at as well.
Okay, we're going to go over to the phone bridge now. It looks like first up we have Marcia Dunn with the Associated Press. Marcia, why don't you go ahead with your question?
Yes, thank you. Could you tell me, please, the size of the SSU, give or take, and how many feet will it be from the airlock to get out to the repair point?
Okay, well, I'll go ahead and take that one. So the SSU is about 2.5 by maybe a little less than a foot wide and about 1.5 feet deep. Weighs something on the order of 200 pounds. So it's a pretty large and bulky, massive thing. The crew definitely has to take care of getting it to the work site. The work site itself is on the order of 200 feet or so from the airlock. It's if you were in a straight line, obviously the crew has to translate around, follow structure, so it's a little bit more than that. So it's about as far in space station as you can go from the airlock, which certainly raises the pucker factor for the crew, I'm sure.
All right, well, also on the phone bridge, we have Jackie from Times of London. Jackie, go ahead with your question.
Hello, thank you. Spacewalk always looks easy, but can you tell us a little about the physical challenges that the crew go through in performing it? For example, the difficulty of performing fine motor tasks in thick gloves. And you mentioned as well that they'll have one spot where they're working in a tight space. Can you just tell us a little bit more about that and what the risks or difficulties of that element are? Thank you.
Okay. So spacewalking is challenging. You have to wear a spacesuit, which is sort of your own independent spaceship to protect you from the harshness of the environment. So there's a trade-off between having as much protection as possible but still maintaining mobility. So imagine going out with thick winter gloves on and trying to do anything that takes fine dexterity. That's going to be challenging. The crew spends a tremendous amount of time practicing before they launch, which gives them a benefit, but it is still a challenging thing and just overall physically demanding. Now, we mentioned the NPV, non-propulsive vent work site, is very tight. One of the challenges there is it's difficult for the crew members to actually reach in. Most likely, they're only going to be able to get one hand on the equipment as they're trying to install it rather than two. And as you can imagine, from any time you ever try and do anything one-handed, if your other hand is occupied, it just makes it significantly more challenging.
All right, do we have any follow-ups here in the room? Mark?
Yes, I'm Mark Crow for Aviation Week. Which of the future IDA locations on Node 2 is the beneficiary of the cabling work?
This will be IDA, it'll actually be IDA 3, which will be the one on Node 2 Zenith, is the one that is being supplied by the white-green cable that we're routing.
And just a short follow-up too, I got lost on which module the vent is on. I think you were very clear at just what, right?
It is going on Node 3.
Okay.
Just a really quick one for me. When is IDA cabling done, other than hooking it up when you move PMA3 and all of that? Is this the last cable run, or is there more beyond this?
So this will be the last cable to be deployed EVA. Once PMA3 is relocated, obviously the cables then have to route from where we've temp stowed them up to the final connection locations. But this will be the last cable that will have to be taken EVA.
Okay, I think Marcia on the phone bridge might have a follow-up. Marcia, do you have one?
Yes, I have two, if you don't mind.
Yeah, go for it.
You have two Tims. How are you going to distinguish between the two in conversation during the spacewalk? That's my first question.
So it's effectively the same as we've been doing it on all the work inside the station. We will start most of the conversations with for Tim Peak or for Tim Copra, but then as the conversation continues, you don't need to keep saying their last name. Reed has worked with both the crew as a Capcom, so this will be just fine.
Yes, and if you don't mind, for Kenny Todd, please. I'm wondering, regarding one-year crews, when do you anticipate having another one-year crew go up?
That's a good question, Marcia. There's still a lot of discussion here within the partnership about the scheduling for another one-year crew. So I would tell you that's still very much a topic of discussion internally, and today it would be hard to put my finger on when that date would be.
All right, thank you, Marcia. And I think that'll do it for today's Spacewalk preview briefing. Of course, you can watch the Spacewalk live as it happens on NASA TV. That broadcast time is going to start at 5:30 a.m. Central Time, 6:30 a.m. Eastern. So it'll be an early morning wake up and tune in and watch. Planned 6.5-hour Spacewalk for Tim Copra and Tim Peak. Thank you for joining us today. That'll do it. Enjoy the rest of your afternoon. Look forward to that Spacewalk. Thanks.